In this video, we will learn on how to solve a solution of nonlinear equation by using Newton-Raphson method. So before we begin, make sure you already prepare your calculator with you so that we can solve it together. So let's do the first example of Newton-Raphson method. Before we start, so just highlight it first. So for Newton-Raphson method, we have a fixed formula of xn plus 1 is equal to xn minus fx of n divided by f prime of xn. Okay, so altogether we will have 5 main steps in order to solve by using Newton-Raphson method. So first, we have to show that the root exists in order to find the root, and then next part, step number 2, we have to find the initial value before we start the approximation. After that, we have to state our fx, our function, and the derivative of our function, which is f prime of x. Substitute this up into the formula so that we can start our Newton-Raphson process. Okay, so let's begin with the first example. Show that the equation of 2 sine x minus x equal to 0 has only one real root at the interval of 1 and 2. Use Newton-Raphson method to find the solution of this equation. Give your answer correct to 3 decimal places. Okay, so before we begin with the Newton-Raphson method itself, we have to show that the equation is actually exists. So for this question, I'll decide to use algebraic approach or algebraic method. So first, for algebraic method, we have to name our function. In this case, I name it as fx. So we have 2 sine x minus x. Next step, substitute the values given in the equation, the values of x. So first one, for f1, we will have 2 sine 1 minus 1. So in this case, we will get 0.68. So this is a positive function, positive value. Next one, substitute the second values of x, f2. So we have 2 sine 2 minus 2. In this case, we will get negative 0.18, and this is negative value. So here we have a change of sign, different sign, positive and negative. Straight away we can make a conclusion. So different sign, or you can use opposite sign between f1 and f2. Okay, so root exists between x equal to 1 and x equal to 2. Okay, so here we already proved that actually the root exists. Now we may begin with our Newton-Raphson process. Okay, so for Newton-Raphson process, first we must define our function fx and our f prime. So fx we already defined before. I just rewrite it first. So our fx just now is 2 sine x minus x. And then find our derivative, or f prime of x. In this case, we will get 2 cos x minus 1. And then we will have to substitute this into our formula of Newton-Raphson, which is xn plus 1 is equal to xn minus fx over f prime. But then here we have to substitute all x with xn because we want to approximate the values of x. So we have to repetitively substitute different value of different values of x into the function. So that's why we name it as xn. Okay, so we will have 2 sine xn minus xn over f prime. So we have 2 cos of xn minus 1. Okay. And then we may start the process by choose first the initial value. So for initial value, you may choose any values of x start between x equal to 1 and x equal to 2. So in this case, I'll just choose the middle value. Here, I'll start with 1.5. So it is an open initial value. If you want to choose, let's say you want to start with 1.3, that's okay too. Okay. Alright, now this initial value, we have to substitute it into our function. So next next values of x would be x1. So substitute 1.5 into our function. So here we will get 1.5 minus with, so we have 2 sine of 1.5 minus 1.5 divided by 2 cos of 1.5 minus 1. Okay, so in order to find the answer, now because we will use this function repetitively, we can input or compute this function into our calculator. Okay, so that's what we're going to do now. First, be careful because this is trigo function, means that for your mode, you must choose radian function. So I choose shift menu, setup number 2 for angle unit, and then I choose number 2 for radian. So we have R here, means that it is in the mode of radian. Now we will substitute this whole function. So we will have alpha x minus with, alright, our function just now. So 2 sine alpha x minus with button next one alpha x. Okay, and then for our f prime, we have 2 cos of alpha x minus 1. Okay, now we may start calculate the value. So just press the calc button, CALC button here. Okay, so they will ask the value of x we want to compute. So our initial value just now is 1.5. Here I compute 1.5 and then equal, double equal. Alright, so now we obtain the first values of x, which is 2.076. 55. Okay, so how many decimal places do we have to write here? It depends on the question. Okay, I change back the original question. Alright, so here, give your answer correct to 3 decimal places. Okay, that's for final answer. For solution, this is the calculation process. At least provide 1 more decimal places than the required in the question. So since the question asks for 3 decimal, means for calculation, I will provide 4 decimal places. So we have 2.0766. Okay, so that's the first approximation value. Moving on, now we have to find x2. So what do we do here? Our first answer, we have to substitute back into our function. So we would have 2.0766 minus with 2 sine of 2.0766 minus 2.0766 divided by 2 cos 2.0766 minus 1. Okay. So, in order to find the next value, you don't have to compute back the function. What do we do here? Just press the equal button. Alright. And then press answer button, ANS, besides the equal button. Alright. And then press the equal button twice. Alright, so this would be the next value of x. In this case, we obtain 1.9105. Alright, so moving on now, repeat the same process. We have to substitute this x into our formula. So x3 would be 1.9105 minus with 2 sine of 1.9105 minus 1.9105 divided by 2 cos of 1.9105 minus 1. Okay, so for this function, we want to find the value. So equal, answer, double equal. So our next answer will be 1.8956. Okay, settle with that. Now, moving on to the next one. Next value of x, x number 4. Alright, so for your calculation, just provide at most 3 steps of this Newton-Raphson. Means you substitute value of x into the formula at most 3 times. At least 3 times. That's more than enough. So for the next value of x, you just have to compute the answer. You don't need to rewrite back it into the formula. Okay, so in order to find the next value, I just repeat the same process. Equal, answer, double equal. So we obtain now 1.8955. Okay, so next value of x, x5. So I put equal, answer, double equal. So here we obtain 1.8955. Okay, now once we get the same answer twice, here 1.8955, we will categorize this as the stopping criteria. Means our answer after this won't change. If you still compute the same value of x into the same function, you will still get the same answer. So you may stop now the Newton-Raphson process. Okay, so after this, we may start approximate our final answer. So our approximate answer x would be 1.89 because the question asked for 3 decimal places. So I stop at 3 decimals. So 1.896. So that's how you perform Newton-Raphson process.